Okay, hello, forensic students. So these are the notes you are going to be using for your forensics timeline. Basically, I'm gonna kind of talk through the notes a little bit, give you some additional information on some of these scientists, and then you're gonna go back and get the information to create a forensics timeline for yourself. So here we go. Basically, let's start off with what is forensic science anyway? So, it is the application of science to criminal and civil laws that are enforced by the police in the criminal justice system. Um, and really, forensic science owes kind of its beginnings to the individuals and scientists who created the principles and techniques that are used to identify and compare the evidence. Um, and there is evidence of, or there are stories, I should say, that go as far back as 3rd century China of science and experimentation being used in criminal cases. So, way back when, there was a man named Yi Yuji. He was kind of like the elder in the community. Um, and he was called on to do some testing on a suspicious fire. So, a man and a woman, husband and wife, their house burned down, and the husband's body was found in the rubble. Now, the community, knowing the couple and knowing the wife, they accused her of purposefully setting that fire and murdering her husband. So the elder in the community, Yi Yuji, I believe I'm pronouncing that correctly, he was called on to kind of test whether or not she was guilty of murdering her husband. So the way he did that was he took 2 pigs, and one pig he killed and then burned the body. The other pig he burned alive. And afterward, he examined both pigs and found that the pig that had been burned alive had soot and kind of burn residue within its mouth. The pig that had been killed and then the body burned did not have any residue inside his mouth. So he took those findings and then examined the husband's body and found that the husband also did not have soot or any residue within his mouth, therefore confirming that he was dead before the house was set on fire, and sort of confirming that the wife most likely murdered him and then tried to cover it up by burning the house down. So we have some scientific experimentation being done way back in 3rd century China. Alrighty, a little bit closer to now, we have Matthew Orfalea, who's known as the father of forensic toxicology. He wrote the first book on detecting poisons and their effects on animals. Excuse me, toxicology is the study of chemicals within the body. And so he wrote the first book on that. Then we have, Alphonse Bertillon, who was the first person to create a scientific method of personal identification. And that method was known as anthropometry. So here we go. Anthropometry was basically just a series of body measurements, and the collection of those measurements was used to identify one person from another. It worked fairly well, although it wasn't perfect at the time, but it worked well enough. Then we have Francis Galton, who came up with the first definitive study of fingerprints and classifying fingerprints. He wrote the first book on it as well, and then used that research in criminal investigations. Leon Lance was the first person to develop a procedure to determine blood type from dried blood stains. We'll talk more this semester about blood type and do some activities on it as well. Well, virtually. And he also obviously applied his procedures to criminal investigations. Albert Osborne was the first person to develop the basic fundamental principles of document examination. So he started out as a teacher of penmanship, which is kind of like handwriting. And then based on that and his interest in that, he his work flowed into then handwriting identification. And then from there, he moved on to studying typewriting and paper and ink. And all of his interests and all of his research and studies led to all of the principles used for document examination, things like forgeries and stuff like that. Kelvin Goddard was the first person to use a comparison microscope to study bullets and guns and casings, things like that, to see if a particular gun fired a bullet. His work was used in a few high-profile cases. Sacco and Vanzetti was a very historically significant case. The Sacco and Vanzetti were two men who were accused of murder in a robbery/murder. And then thanks to Goddard's research, he found that the casings, the bullet casings left at the crime scene did in fact match the weapons found on Sacco and Vanzetti. He also used his research in the St. Valentine's Day Massacre, which is a pretty famous, historically famous event where it dates back to like the Al Capone mobster days, where the gangsters lined up a bunch of men and basically just shot them in the back at point blank range. And so he used his techniques to again compare the bullet casings left at the crime scene and was able to match them to the weapons found at the gangsters' hideout. And so they were able to catch those guys. Walter McCrone used microscopy and a few other various techniques to examine evidence. He, however, is known as the father of modern microscopy, so much so that there is a research institute in Chicago named after him. So a lot of work done with microscopy and evidence for sure. Hans Gross, he happens to be the man who pretty much started forensic science. He was the first one to write anything with regards to describing how to apply scientific principles to criminal investigations. And not just a particular field of science, but all different studies, not just microscopy, but chemistry, physics, zoology, botany, mineralogy, all different areas of science. And their principles can be used and applied towards criminal investigations. Edmund Locard took Hans Gross's work and followed in his footsteps. He created the very first workable crime lab, which he put in an empty apartment above a police station in Lyon, France. And he did such amazing work and grew his studies and his research to then become the founder and director of the Institute of Criminalistics at the University of Lyon. Criminalistics is the area within forensics where you basically study the evidence, analyze different types of evidence. Locard also became very well known for his exchange principle, which says that when two objects come into contact with one another, there is an exchange of material between them. So basically, if a criminal comes into contact with an object or a person, there's a cross transfer of evidence. So not only do you leave evidence behind of where you were, but there's evidence on you as well from the places you were at and the people you interacted with. And it can be very, very small trace evidence, but there is that cross transfer of evidence that takes place. So there you have it. That's the end of our notes. Like I said, you can go back and replay certain parts of this video. You can pause wherever you need to create your timeline. I have the instructions on a Google slide, but just to clarify, you are going to include in your timeline the name of the scientist, the year, what they were primarily known for, and then a picture drawing of kind of going along with the principle they were known for. If you're doing it digitally, you can insert a picture. You can find a picture on Google. I'm okay with that. The one thing that you do need to note is that your timeline must be in chronological order. I'm going to back up a little bit on these slides. The information that I presented, if you notice here, was not in chronological order. So you will have to go back and make sure you really pay attention to those years and put them in chronological order. You do not need to include Mr. Yi-Yu-Ji in your timeline. So there you have it. If you have any questions, you can always contact me. You can pop on Zoom during our class time, or just shoot me an email or write a comment in Google Classroom on the assignment. All right, friends, have a great weekend. You've made it through your first full week of remote learning. You guys should be proud of yourselves. Great job.